Okay, so 3.2, 3.3, and 3.4 are 3 units that were not covered on any quiz thus far, but they will be on the first exam. So that makes them very important because they're not just on the first exam, but you will see about a quiz's worth of questions on the exam with regard to these 3 subjects. And that makes it important, right? Because you can't drop an exam, you can drop a quiz. So you'll essentially have a quiz that you can't drop on these 3 subjects. So just getting into them. So the stuff to memorize is, we've got the product rule and the quotient rule, the chain rule, and the trig derivative. So there's not too much to just straight up memorize here, but there is a lot of applications. And this is also just like the majority of Calc 1 is derivatives. And the product rule, quotient rule, and the chain rule are the 3 rules that you will be using to take derivatives for the remainder of the semester. So it's very fundamental. It's very important for the rest of the semester. This isn't like the precise definition of the limit where you just kind of won't see it again. So if we're going to find the derivative of this is a product rule question because we have a product, right? We're multiplying 2 different terms together. So I'll break it down into U and V. Red will be our U, and V will be our blue. And you can use f of x and g of x if you want. I believe I put it in both forms on this slide. Really just whichever one you're more comfortable with. I personally learned on U's and V's, but however you know it is totally fine. So the form that the product rule is U prime times V plus UV prime. And just a little note is that, it doesn't really matter what order these are in. Right, you could do, this is the same thing as UV prime plus U prime V. They're equivalent just because you're adding them, you're not subtracting them, you're not dividing them, stuff like that. So you can write these in either order. The order does matter for the quotient rule, but for the product rule, it doesn't really. So let's just get into it. The derivative of our U term, so our U is 4x squared minus x. So we take the derivative of it, and this is just a simple power rule problem, right? So that 2 comes down, multiplies with that 4 to give us 8, and then we subtract 1 from the power. 2 minus 1 is just 1, so we just have 8x, and then it'll be minus 1 because the derivative of negative x is just negative 1. For V, also power rule, right? That 3 comes down, we drop the power by 1, we get 3x squared. We drop the 2 down in front, multiplies with the 8 to give us 16, then we drop the power by 1, that's 16x, and then the derivative of 12 is 0 because it's just the derivative of a constant. So then we want to go and we want to plug this into our product rule formula. U prime is 8x minus 1. Here, I'm going to use yellow actually. So we get 8x minus 1 times V, which is just this term. So that's x3 minus 8x squared plus 12, straight up copying it from the problem. And then plus U, our U is just this, 4x squared minus x. And then our V prime is 3x squared minus 16x. Okay. So then that would be our answer there. So this whole thing would be our answer there. You generally will not have to expand these and quote unquote simplify them. You will generally be able to leave it like this and just circle it. Okay, now find f prime of x. So this is another product rule problem, so we'll do the same thing as above, where we will have U be our red term and V be our blue term. So the derivative of our U term, the derivative of 1 is just 0. X, the square root of x cubed can be rewritten as x to the 3/2 power. So we will do that, and that'll let us take the power rule of it. That 3/2 comes down in front, x, and then we want to subtract 1 from the power, which will be 1/2. So U prime equals 3 times the square root of x divided by 2. As for our V, we have x to the negative 3, so that's a power rule, so that negative 3 comes down in front, and then we subtract 1 from the power. Negative 3 minus 1 is negative 4. And then this minus 2 x to the cube root of x, that's x to the 1/3. So that becomes negative 2 times 1/3, so negative 2/3 times x, and then we subtract 1 from 1/3. 1/3 minus 1 is negative 2/3. So v prime equals negative 3 times x to the negative 4 minus 2 over 3x to the 2/3, because we get rid of that negative exponent by bringing it down into the denominator. And then we should also probably rewrite this as negative 3 divided by x to the 4th. Just generally a good rule of thumb to get rid of your negative exponents. So then we would plug this into our product rule formula. And so that would be 1 plus square root of x cubed. And then our v prime would be negative 3 divided by x to the 4th minus 2 divided by 3x to the 2/3 power. And just keep everything in parentheses, plus, and then our u prime is going to be 3 square root x divided by 2. And then our v is just x to the negative 3 minus 2 cube root of x. So that would be our answer there. Okay, so another way you could be asked these kind of questions is kind of similar to how we were talking about last week, where you can be asked derivatives within the context of acceleration, velocity, and position, right? So just knowing that velocity is the derivative, position is the derivative, or the derivative of position is velocity, and the derivative of velocity is acceleration. So if we have this, we have our velocity function, we can find the acceleration function by just taking the derivative of it, right? So this is going to be a quotient rule, and if we go back up here, this is our quotient rule, u prime v minus uv prime over v squared. And it's important to note that the u prime v comes first, because unlike the product rule, the order is important in the quotient rule, because if you mix these terms up, right, if you did this, you get the idea. If you swap the terms around, then you're going to get the wrong answer because you're going to be subtracting the wrong term. So u is always what's in our numerator. So that's 3t plus t to the 4th power. V is always what's in our denominator, 2t squared plus 1. The derivative of 2t squared plus 1 is just 4t, right, because that's power rule, and then the derivative of 1 is just 0. And then for u, the derivative of 3t is just 3, and the derivative of t to the 4th power is a power rule problem, which that 4 comes down, and then we drop the power by 1. So then we just plug this into the quotient rule formula. U prime is 3 plus 4t cubed times v, which is 2t squared plus 1, minus, and then u, which is just our numerator, so 3t plus t to the 4th power, times our v prime, which is just 4t. And then we divide all by v squared. V is 2t squared plus 1, so we just put parentheses in it, square it, and we will leave our answer like this. And generally, you can leave your answer like this. Okay, so then find the slope of the tangent line. So slope of the tangent line is the same thing as the derivative at a certain point. So in order to first find the slope of the tangent line, we need to take the derivative of our function. And the derivative of our function is going to be a quotient rule problem, where our numerator is ru, and our denominator is rv, right? So the derivative of our denominator is going to be 7 minus 8x, and then the derivative of our numerator is going to be, right, because x squared can be rewritten as x to the 1/2 power. So if we do that with the power rule, that 1/2 comes down in front, x, and then we subtract 1 from the power. 1/2 minus 1 is negative 1/2, and then plus 2. because the derivative of 2x is just 2. So u prime equals 1 divided by 2 square root x plus 2. So now we just need to plug this into our quotient rule formula. So we get that x, or f prime of x equals, oh crap, where's our quotient rule? There we go. U prime is going to be 1 divided by 2 square root x plus 2. Sorry, I should put this in red. 1 divided by 2 square root x plus 2 times our v. Our v is just 7x minus 4x squared minus our u. Our u is just square root x plus 2x, and then times our v prime, which is just 7 minus 8x. And then that's all divided by v squared, so just our denominator squared. So that is 7x minus 4x squared, and we just square it, leave it like that. And then if we wanted to find, so this is probably not a problem you'll see on a quiz or an exam, just because you would have to plug in 3 and this would get really ugly. So I'm just going to erase every x and write a 3. There are ways you can simplify it, but you probably wouldn't be given something this algebraically messy on a quiz or an exam. So something like this. Something like that. And then you could simplify that, but again, you probably wouldn't be given something this complicated of a simplification on a quiz or an exam. So, but you could. Okay, so then there are problems that have both a product rule within a quotient rule or vice versa. So these get pretty messy. But it's important to step through at least one, because like on the final exam, you'll almost certainly see a problem like this. You'll probably even see a problem like this on the first exam, if I had to guess. But just being questions that test multiple of these rules, like chain rule, product rule, quotient rule, questions that test multiple of those in the same question are very popular. So we would just step through this, start with our quotient rule, because our whole thing is a fraction, right? Our whole thing is a fraction, so the whole thing is going to be a quotient rule problem. So let's start with our numerator, which we will say is our u, 10x squared times 4x plus 9e to the x. Then let's have our denominator, cube root of x, cosine x. Derivative of our numerator is itself going to be a product rule problem, where our first term is 10x squared, and our second term is 4x plus 9e to the x. So then we take the derivative of those terms, that's 20x over here, and then 4 plus 9e to the x here, because the derivative of 4x is just 4, and then 9e to the x derivative, that's 9e to the x, because the derivative of e to the x is e to the x, right? So then our u prime, is our quotient rule is, our product rule is this. So we take our u prime, which is 20x, multiply it by our v, which is 4x plus 9e to the x, plus u, which is just 10x squared, times v prime, which is 4 plus 9e to the x. So that will be our u prime for our overarching quotient rule. So then we go to our denominator, and this is also a product rule, right? So v prime is going to be a product rule, with our first term being the cube root of x, which can be rewritten as x to the 1/3. And our second term is cosine x. And then the derivative of x to the 1/3 is that 1/3 comes down in front. We subtract 1 from the power. 1/3 minus 1 is a negative 2/3. Our v prime is going to be negative sine of x, and this is a trigonometric derivative that you need to unfortunately, just memorize. So, but then we go to put it all together, and we get, so we kind of go across with the quotient, or with the product rule, right? So that's negative sine of x times x to the 1/3 plus 1/3, or sorry, we can bring this x down in the denominator, right? And just take the negative exponent away. So if we extend this denominator like this, we have that. So plus 1/3 x to the 2/3 times cosine x. Oh, and then, yeah. So that would be what we would get here. So that's our v prime. So then we need to put this v prime and this u prime into our final overarching quotient rule, right? So our final overarching quotient rule is u prime. So I'm going to attempt to just copy paste this. I'm actually going to move this thing up a little bit. So it would be, so that's our u prime. I'm actually going to add a new page. As you can see, this gets really messy. So this is our u prime. And then we do u prime times v. V is square root 3 cosine x minus u. Our u is this. So it's all really just a puzzle when you think about it, right? You're just fitting things into different places, and sometimes there's a puzzle within the puzzle and stuff like that. And we got v prime, which is this. So something like that. And then we just divide by v squared, which will be this. And then we just square the whole thing. So very time consuming, a lot of places where, you could potentially trip up. But if you just take it step by step and, just keep a cool head, you will be totally fine. It's really just product rule and quotient rule, and they happen to be in the same problem. So just leave yourself enough time on quizzes and exams to work through problems like this, and you will be totally fine. Okay, and then the last rule that we have to talk about is the chain rule. I actually want to start with 7. So the chain rule is f prime. So if you take the derivative of a function within a function, so to speak, you'll get f prime of g of x times g prime of x, where f is the outside function and g is the inside function. So what that means is, in this scenario, our f of x, or our outside function, is 36 times 6 to the x. And then our g of x is e times x. And you can kind of think of it like e times x is being plugged into f of x everywhere we see an x. That's how you can kind of think of it, and how it's almost like a function within a function, basically. And the issue is we can't just take the derivative of this, right? Because there's an x in the exponent. So we don't really know how to just do that without this being simple. So but we know how to take the derivative of this, and we know how to take the derivative of this. So the chain rule offers a cool way to figure out how to do that. So the derivative of f prime of x is going to be 36, right? Since it's a constant coefficient, it just kind of hangs out front. It doesn't really bother anyone. But then if you remember from last quiz, or last week I should say, the derivative of anything with x in the exponent is the natural log of the base times just the thing again. So that would be our derivative of f of x there. And then the derivative of e to the x is just e, right? Because e is a constant. It's a constant coefficient. So it's essentially the same thing as taking the derivative of 5x, right? Take the derivative of that, it's just 5. Same thing here, because e is just a number, the same as 5. E is like 2.7 or something like that. So that is what we have here. And now we just need to plug it into our chain rule formula. So f prime of g of x just means we write down our f prime of x. But instead of writing x, we write g of x. Our g of x is e times x. So instead of x, we will write e times x. And then now we need to multiply everything by g prime of x. So that's just e. So if we wanted to simplify this, we could say 36 e ln 6 to the ex, or something like that. So that's what we would get there. And, I really can't encourage enough just doing problems with this. Use like Paul's online math notes or organic chemistry tutor. Just find problems with worked solutions online and just do reps with the product rule, the quotient rule, and especially the chain rule. Because the chain rule is like, you really have to get a feel for it. Like, you can know the formula, but it's still like confusing. So I definitely encourage you to do a lot of problems with the chain rule because it really is a feel-based formula. So, and then even if you do know the chain rule, this question can be tricky because just of the way it's worded. So I want you to see this because even if you know the chain rule and you see this question, you might still be confused because it's just kind of really weirdly worded. So if you ever see something like this, h of x equals f of g of x, and then it asks you to find the derivative of h, right? And that's asking you to find h prime or h prime of a certain number or something like that. So if it's asking you to take the derivative and it tells you that something is equal to a function of a function, right? Then you should know, okay, we're going to be using chain rule because we're taking the derivative of a function of a function. So we know the chain rule. That's f prime of g of x times g prime of x, where g is the inside function. So we can, and then now, so that's h prime of x. So if we want to find h prime of 1, we just, instead of writing x, we just write 1. So then h prime of 1 equals, and let's just go through it. What is g of 1? Well, it tells us 3. So f prime of 3 times, what's g prime of 1? It tells us right here, it's 10. So let's go through it again. What's f prime of 3? 20. 20 times 10 is 200. So h prime of 1 is 200.